everyone. Welcome to today's summit. Last year, Huawei published the Intelligent World 2030 report. Together with our customers, partners, and other industry experts, we explored how to drive development in major sectors. The rapid development of technologies is helping us move even faster toward the intelligent world. We believe a better multi-sensory connectivity will bridge both time and space. Digital technology will continue to reshape the production, and AI will become central to almost every production process. Digital technology will also become a key enabler of the green development and help the world go low carbon more quickly. In the future, individuals, households, and industries will have higher requirement for the digital infrastructure. As always, we are relentless in our pursuit of a better experience. Immersive services like XR and holographic communication are maturing, and the connectivity experience will increase from 1 Gbps per second to 10 Gbps per second. Mobile DOU will surge from today's 15 GB to 100 GB. The requirements for latency and ubiquitous connectivities will also increase. For households, the demands generated by advanced services like 24K 3D VR games and holographic education and meetings is creating a full fiber 10 Gbps per second era. For industry, digital transformation is now in a fast lane. This requirement for connections, quality, and awareness are diversifying and increasing. Industrial robot control will require microsecond latency. Power grid dispatching will require 6 nines network availability. Digitalization across industry will also drive explosive growth of the demand for both the computing power and storage. For example, the training data needed for a single autonomous vehicle can reach the 180 PB in volume. Digital infrastructure must continue evolving to support future requirements. And so, we have defined standards for both 5G and F5G to drive service development in the 5G era. Our current level of technological development cannot support the more diverse and complex requirements of the future. This means we must continue to work hard. If we hope to reach an intelligent world by 2030, therefore, the 5.5G era is an important milestone on this path, one we cannot miss. In the 5.5G era, we will need ubiquitous 10 Gbps per second experience, intelligent and high-quality computing scaling, highly autonomous Level 4 networks, cloud-native 2.0 services for enterprises, and a 10-fold increase of the computing power, storage, and infrastructure performance. Now, let's take a look at these 8 facets of this vision. In 2020, we worked with industry partners to define a vision for 5.5G. After 2 years of the hard work, research into the 5.5G for 3GPP Release 18 standards has already begun. As we continue forward, we must take 3 steps. First, more spectrum must be allocated for 5G and eventually 5.5G. The mobile industry is currently promoting IMT tags for the upper 6 GHz bands. The industry is also planning to put millimeter wave into commercial use by 2024 or 2025 to achieve the downlink rates of 10 Gbps per second. In addition, solutions like XR Pro are expected to increase the number of immersive XR service users in each cell by 5 times. Second, technological breakthroughs in IoT, such as with optical rays, location precise, and advanced intelligent sensing, must be made to open up new industrial application scenarios. For example, integrated sensing and communication technology will enable networks to sense the status of vehicles and joints through in-air interfaces. In addition, passive IoT will be able to use 5.5G base stations to activate and connect passive tags using wireless signals. This will create a new blue ocean market for the hundreds of billions of connections. Third, integrated space-air-ground networks will also present new opportunities for 5.5G and vice versa. The industry is already discussing collaborative development plans for wireless and satellite spectrum. We will be able to make breakthroughs in satellite communications by leveraging the experience we built in 5.5G and related technologies. And so, first, we must promote the allocation of the several hundred GHz bands for the 5.5G and continue exploring new 5.5G use cases together. These use cases will be able to create even greater commercial and social value for all. Similarly, in April, Huawei proposed F5.5G, an evolution of F5G, aiming to boost network bandwidth and the number of the connections by a factor of 10. This evolution also targets three new directions of network development: growing agile optical networks, real-time resilient links, and optical sensing and virtualization. F5.5G uses next-generation technologies such as 50G PON, Wi-Fi 7, and 800G to improve the network speed from 1 gigabit per second to 10 gigabit per second. F.5G can also provide real-time resilient links through technologies like high-density time slots and lossless multipath protection. This will improve network performance from carrier grade to industrial grade. This means microsecond level latency and 6.9 availability in industrial setting. F5.5G also extends optical communication to optical sensing by using optical fiber scattering to detect vibrations, stress, and temperatures. Optical sensing can achieve meter-level accuracy. This paves the way for the new application scenarios and business value. For example, intelligent inspections of the oil and gas pipelines. So now we can define the paths forward within the frameworks of standards organizations such as ETSI and ITU. We will also need to work closely with vertical partners to explore more F5.5G business scenarios. In addition to wireless and optical, we must also look at data communication. As the digital transformation deepens, intelligent application widely used in smart city and smart factories will see large-scale commercial use, making computing power even more important. Enterprises will require sufficient computing power that is affordable, agile, and flexible. Therefore, we must continue to innovate based on IP version 6 and develop a technological system for IP version 6 enhanced. At Huawei, we call this space Net 5.5G. Net 5.5G is our vision for the next generation data communication networks. It covers 6 aspects: growing ultra-broadband, massive heterogeneous IoT, high resilience, and low latency connectivities, IP version 6 enhanced, multiple domain network AI, and ubiquitous network security. By upgrading to Wi-Fi 7 and 800G, growing ultra-broadband can deliver 10 gigabit per second access for mobile users, homes and office campuses, and ensure high end-to-end network bandwidth. IP version 6 enhanced, multiple domain network AI, and ubiquitous network security will give enterprises quality and secure multiple cloud networking. This will enable the convergent sensing and scheduling of cloud and computing resources. Higher resilience and low latency connectivity can interconnect millions of computing nodes. This will drive the development of advanced industrial networks that offer high resilience and low latency. Massive heterogeneous IoT connects devices that are used in industry and on campuses. By coming together and quickly reaching a consensus on the evolutions towards Net 5.5G, we will be able to explore new business scenarios and standards and unlock great value for the industry. While we first proposed the concept of an autonomous driving network in 2018, it has matured over the past few years. We have already driven the evolution of partially autonomous level 2 networks to conditionally autonomous level 3 networks. And by 2025, we expect to achieve highly autonomous level 4 networks. Level 4 networks will require a 3-layer AI architecture. First, at the network element layer, AI native will turn traditional network elements into intelligent network elements. Second, at network control layer, the digital twins and foundation modes will improve efficiency. Third, at the service layer, and intelligent service agent will enable closed-loop management. Network-wide autonomy will deliver superior experiences with zero wait times, zero touches, and zero faults to users, and support self-configuring, self-healing, and self-optimizing for the network operators. So our next step in this area are clear. We must define a profile for level 4 and level 5 autonomous networks and make breakthroughs in related basic theory and foundational technologies. We must also build a platform for industry academia collaboration to promote unified standards. Next, in the 5.5G era, we will need to redefine computing architecture to support diversified computing resources. We need to achieve a 10-fold increase in computing power by 2025. This will require 3 big changes. First, at the chip level, we will need to improve the chip engineering to improve the compute density by 2 to 3 times. Second, at the computing node level, we will need to move past traditional CPU-centric architectures and work on peer-to-peer computing architecture. This will significantly improve computing efficiency. Third, at the data center level, we will need to continue reshaping cluster computing and diversify computing architecture. This will help turn data centers into the supercomputers to significantly boost performance. The effects of these 3 advancements will be very clear. For example, by increasing computing power, we will be able to narrow down the granularity of the weather forecasts from 10 square kilometers to under 1 square kilometer. By pursuing system-level innovation as an industry, we will be able to redefine this computing architecture and improve the computing performance and efficiency. As the data application diversify and become more time-sensitive, storage system will also need to become more data-centric. We will need to redefine storage architecture and increase storage performance by 10-fold. At hardware level, we can use high-throughput global data buses to integrate DDR memory buses with the system PCIe buses. This will make data flow faster from 5 gigabit per second to more than 50 gigabit per second. Software architecture can be adjusted to separate the data plane and the control plane. Reducing data access latency from 100 microsecond to 10 microsecond. We can also use the data application acceleration agent for the near data processing to increase the data processing efficiency by 5 to 10 times. The ultimate goal of storage system advancement is to store more data, ensure that data can flow smoothly and be easily accessed, and offer consistent experiences, both on and off the cloud. Here, we need our industry partner to jointly define a storage architecture that meets diversified data processing requirements and boosts performance. Huawei proposed the Cloud Native 2.0 in 2020. This idea has already taken hold across the industry. By 2025, more than 95% of enterprise applications will become cloud native. Cloud Native 2.0 is based on the concept of the everything as a service. First, infrastructure as a service. Global data center and networks and distributed cloud native technology will reduce cloud access latency to 50 milliseconds. Second, technology as a service will unlock huge potential for industry. We provide 4 such pipelines for software development, AI development, digital content, and data governance. These pipelines can shorten up time to market to 10 minutes and enable intelligent generation of 40% of code. Finally, we also offer expertise as a service. By sharing best practice in digital transformation, we can modernize and recombine enterprises' applications across the entire ecosystem. By working together with ecosystem partners to make everything as a service with Cloud Native 2.0, we can create a thriving cloud service industry ecosystem. Finally, let's talk about green and sustainable development in the 5.5G era. If we want to effectively fight climate change, we must fund innovative ICT solutions in 3 areas. First, we need to offset the growing energy consumption by making digital infrastructure more energy efficient. To do so, we have proposed the Unified Network Carbon Intensity Index to assess the energy-saving policies of the entire networks. We have also released a 3-level green solution that covers sites, networks, and operations to improve the network energy efficiency by 10-fold by 2025. Second, we need to integrate, innovate digital and power electronics technologies to increase the share of renewable in our energy mix. Third, we need to use the digital technology to help different industries go low carbon, especially carbon-intensive sectors like electric power, industry, transportation, and buildings. We believe that by 2030, digital infrastructure will become 100 times more energy efficient. More than 50% of electricity will come from renewable energy, and 50% of business will take their digitalization to a new level. We are now calling for the industry to adopt a unified NCIE system. By working together to explore new digital technologies, we can accelerate industry digitalization and decarbonization. 5.5G will be a key milestone on our path to an intelligent world. These 8 approaches are critical to creating a strong and sustainable 5.5G era. To achieve our ambitious goals for 2030, we must first embrace 5.5G. And so today, we are releasing a new series of white papers that will help us stride towards the intelligent world. These papers will explore the industrial paths that we can take toward the intelligent world. The white papers were written based on the decades of the technical expertise and insights Huawei and our partners have developed pursuing the 5.5G era. Next, my colleague, Mr. Dang Wenshuan, will discuss the contents of these white papers in more detail. The journey of 1,000 miles begins with a single step. Let's work together to embrace 5.5G and stride towards the intelligent world. Thank you.
Thank you, David, for your insightful speech. And now I will discuss these white papers in more detail. Our shared future will be an intelligent one, but we still have a long way to get there. The widespread 5G, cloud computing, and AI applications are giving us a glimpse into that future, while in addition, the increasing number of smart devices and applications we use every day is proof that we are already on our way to an intelligent world. During this process, we have also seen that ICT infrastructure, which is essential to the future intelligent world, still needs to improve in many areas. This improvement will not be achieved overnight. It will be an ongoing process. If we want to reach a truly intelligent world sooner, while considering business viability, we must be able to identify and respond to key trends. There is a lot we can do by year 2025. So we at Huawei have written a series of white papers that dive deeper into this topic. We believe that two pillars underpin our vision for the intelligent world: ICT for intelligence and intelligence for ICT. ICT for intelligence is about constantly innovating and evolving in different ICT domains to improve key capabilities. This is about how ICT will bring us closer to the intelligent world. And intelligence for ICT is about how the ICT industry will become more intelligent and pursue architectural innovation to address these challenges it faces. These challenges include more complex O&M, ensuring user experience in diversified service scenarios, and green development. Addressing these challenges will help us make the most of existing and coming core ICT capabilities and lead us to the intelligent world faster. The 8 white papers I will brief today talk at length about the key ideas and innovations along these two pillars. First, let's take a look at the wireless network domain. 5G has greatly improved the mobile user experience. The cost per bit has dropped sharply, and new consumer behaviors have formed. In the 4G era, SD video was the mainstream. In today's 5G world, 60% of video is already HD. Many new mobile use cases are now emerging and gaining popularity these days. Short videos, live streaming, e-commerce, and virtual concerts with tens of millions of viewers, to name just a few. New user behaviors have redefined standards for user experience, changing the rules of the game. And these behaviors are also driving surges in mobile traffic. We predict that by year 2025, as a service like XR and new calling mature, average mobile data traffic per user per month, or DOU, will increase from 15 gigabyte to 100 gigabyte. And the data rates will increase from 1 gigabit per second to 10. To prepare for these changes, the mobile industry should focus on several key areas. First, we must free up more spectrum across different bands for 5G to build a universal mobile broadband network. Second, we need to begin deploying millimeter wave and 6 gigahertz around 2024 or 2025 to support these spikes in data traffic. Third, we must introduce AI to our wireless network to make them more autonomous and intelligent. Finally, we need to define and shape the development of the 5.5G. Now, I will expand a little bit on spectrum resources. Currently, there is a few hundred megahertz available for most operators, including new mid-band TDD spectrum and existing IFDD spectrum. This can largely support gigabits per second and 15 gigabyte DOU. After 2025, the telecom operators will each need at least 1 gigahertz of spectrum to deliver a 10 gigabits per second user experience and support over 100 gigabyte DOU. Making the most of sub-100 gigahertz spectrum is the key to achieving this. How do we do it? First, we can reform sub-6 gigahertz bands to make them work for 5G. And in the future, we may leave low-frequency bands only for 4G and other video access technologies. Second, we should consider deploying 5G network over new bands with ultra-large bandwidths, such as millimeter wave and 6 gigahertz bands. Also, to maximize the potential of 5G, we must apply innovative technologies, such as enhanced massive MIMO, to increase mobile coverage in high-frequency bands. The rapid development of wireless network is raising new requirements for network architecture. This includes how to ensure superior user experience across diverse B2B and B2C services, how to simplify O&M for massive numbers of sites, and how to reduce energy consumption as data traffic surges. AI is the obvious solution. That's why we have proposed Intelligent RAN. It has two parts, intelligent base stations and the intelligent management platform, iMaster MAE. With this new architecture, we can create digital twins of wireless networks through data reconstruction, use layered AI engines to support diversified AI application scenarios, and enable layered autonomy for network elements and the management platform through multi-target management and intelligent decision-making. The idea behind this is to build AI-native wireless network with zero-weight provisioning, optimal experience, and energy efficiency, zero faults, and continual learning and evolution. The ultimate goal of Intelligent RAN is to achieve autonomy in the wireless network domain. The evolution of wireless network is a key step towards the intelligent world, and Huawei has proposed a vision for 5.5G. The goal of this vision is to improve the basic performance of 5G wireless network by 10 times, achieve AI native and 10 gigabits mobile experience, and support 100 billion IoT connections. As I have already mentioned, delivering a 10 gigabits experience with sub-100 gigahertz and achieving AI native with Intelligent RAN are key to the 5.5G vision. To make 5.5G a reality, we also need new technologies like uplink-centric broadband communication, RedCap, and passive IoT to better support 5G TV and massive IoT connections. This is how we will accelerate industrial digital transformation. We also need to use integrated communication and sensing to explore new native services for wireless network. The industry widely recognizes 5.5G as the way forward. But to take the 5.5G industry to the next level, we must jointly develop standards and clarify the directions for key technologies such as ultra-large bandwidth, optic spectrum reconstruction, passive IoT, green air interface, and AI native. And now let's move on to core network. VoLTE and VoNR have emerged as the basic 5G voice network because of the quality voice experience they can deliver and the reduced use of spectrum for 2G and 3G. Currently, over 95% of operators that have commercialized 5G have deployed VoLTE, and all new mobile phones support VoLTE. In year 2021, VoLTE penetration reached 42%. Operators have also started developing video calling services. Compared with the OTT video calling, new 5G video calling is more user-friendly and delivers higher definition and better quality. With new AI and interactive capabilities, new calling will offer more new features such as phone calling and remote assistance, making calls more enjoyable and interactive. We believe that video calling will see a boom in the near future, with a penetration rate of more than 15% by 2025. To support richer user experience, core network must undergo 3 key changes. First, support full service enablement. And second, adopt AI to make core network autonomous and intelligent. Third, the industry must come together and define and shape the development of a 5.5G core network. To build a core network that features full service enablement, we need to constantly improve the basic capabilities in 3 areas: new calling, video, and multi-access edge computing, or MEC. In terms of new calling, we need to introduce data channel and technologies like real-time rendering to deliver intelligent and interactive core experience. The future of video is volumetric and social. Therefore, frame scheduling and converged video and communication technologies will be essential. We also need to improve MEC reliability and private WAN capabilities and extend industry private networks from limited scenarios at certain size to all scenarios anywhere. The rapid development of a core network will raise new architectural requirements. This includes network-wide stability and reliability, optimal user experience for diversified services, and 7,000 parameter configurations. We believe that introducing AI is a must to meet these requirements. Therefore, we have proposed Intelligent Core. It consists of 2 parts: Intelligent Core Network Elements and iMaster IMAE-CN. Based on this new architecture, we can create digital twins of core network and analyze and operate live network through simulation. These layered AI engines to meet these needs of diversified AI application scenarios enable layered autonomy for network elements and the management platform through intelligent decision-making, and improve the cognitive capabilities of a network through continual learning. A native core network will allow for zero-touch network configuration and zero network interruption with better lossless user experience. Ultimately, Intelligent Core will achieve autonomy in the core network domain. As an essential part of mobile 5.5G network, core network must continue to evolve. To this end, Huawei has proposed its vision for 5.5G core, which has 6 major components: trustworthiness, automation, cloudification, MEC to everywhere, new calling, and new video. This combined will support full service enablement. In addition to defining standards together, we must clarify the directions for key technologies such as data channel, frame scheduling, all-scenario MEC, and AI native, in order to achieve the development of 5.5G core. Now, let's look at all optical network. Multiple factors are driving an explosive growth of all optical network around the world, ushering home network into its golden age. Today's homes are no longer just living places. They are multifunctional centers where people play, work, learn, and exercise. Smart home devices have grown from dozens to hundreds, propping up the development of gigabit homes as new services like XR and smart homes continue to develop and mature. We can expect more and more 10 gigabit homes. New FTTH technologies such as Blade LLT and digital ODN are making FTTH deployment easier and cheaper. With innovative FTTR solutions that bring fiber to every room, operators will be able to provide quality Wi-Fi experience for consumers while boosting their ARPU by 30%. In addition, many countries have launched digital strategies to provide policy support for our optical deployment. Based on these trends, we predict that global FTTH penetration will increase from 28% in year 2020 to 40% in 2025. During the same period, gigabit FTTH penetration will soar from 1% to 26%, and FTTR penetration will reach 8%. Leading markets will start shifting from gigabit FTTH to 10 gigabit FTTH in 2025. To prepare for this change, the all-optical network industry needs to take 4 actions. First, accelerate FTTH deployment while increasing FTTR penetration. Second, start commercial 50G PON and Wi-Fi 7 deployment around 2024 or 2025. Third, apply AI to optical access and transport network to make them autonomous and intelligent. Finally, work together to define and shape the development of the fixed 5.5G. To deliver a ubiquitous 10 gigabit experience, we can consider several measures from the perspective of network evolution. First, move from FTTH to FTTR and from Wi-Fi 6 to Wi-Fi 7 for homes. Second, involve OLTs from GPON and 10G-PON to 50G-PON. Third, upgrade metro and backbone networks to increase transmission from 100G or 200G per lambda to 400G or 800G per lambda. This will support higher access bandwidth and larger user bases. In addition, we need to widely deploy optical cross-connect, or OXC, as this will be necessary to further reduce transmission latency, enable one-hop connection, and improve user experience. The rapid development of our optical access network brings some new requirements, including premium experience for home users and precise O&M for massive numbers of devices and dumb fiber resources. Once again, AI will be essential here. For this, we have proposed Intelligent Fan, which has 2 parts: intelligent network elements including FTTR, ODN, and OLT, and iMaster NCE fan. Based on this new architecture, we can create digital twin of our optical access network through digital modeling, support the application scenarios of all optical access network through layered AI engines, and enable layered autonomy for network elements and the management platform through intelligent decision-making. AI-native all-optical access network will deliver a ubiquitous gigabit or even 10 gigabit experience and enable precise operations and elastic planning. The ultimate goal is to achieve the access network domain autonomy and bring digital to homes and industries. To adapt to new changes, future optical transport network will also need to address some key requirements. This includes deterministic optical connectivity for home, enterprise, and cloud, and OTN private networks that deliver a premium user experience. For this, we have proposed intelligent OTN. This also has 2 parts: network elements including OXC and OTN, and iMaster NCE T. Based on this new architecture, we can create digital twin of our optical transport network through digital modeling. Use layered AI engines to support the AI application scenarios of our optical transport network and enable intelligent decision-making. AI-native optical transport network will deliver ultra-broadband, low latency, and highly reliable transmission, SLA-guaranteed services, unattended network O&M. Ultimately, they will achieve the transport autonomy. As an important strategic step for fixed network, enabling an intelligent world, Huawei proposed fixed 5.5G in April 2022. We constantly enhance the three capabilities of F5G and have added three new capabilities. These capabilities will bring about 5 changes. The first two are the AI-native feature and ubiquitous 10 gigabit experience I have already discussed. The third is industry-grade real-time resilient connectivity that cuts latency to microseconds and increase availability to 6 nines. This will better enable industrial digital transformation. The fourth change is replacing electrical components with optical ones and upgrading to an all-optical network architecture. This will bring a 10-fold increase in energy efficiency and enable green, sustainable development. The last change is evolution from optical communication to optical sensing. This will bring the environmental monitoring area down to 1 meter, leading to scenarios and applications that go beyond connectivity. Moving forward, we hope to keep improving F5.5G together with our industry partners and drive fixed network forward. Next, let's look at data communication. Huawei's data communication solutions cover campus network, web area network, and data center network. In terms of campus network, all wireless office has become the normal. In addition, a rise in cloud-based services and HD video conferencing means gigabit connections have now become a basic need. Moving forward, XR collaboration and more cloud applications will lead enterprises into the 10 gigabit era. For WAN, or wide area network, multi-cloud adoption and IoT are driving the rapid development of IP network. Multi-cloud strategy has become the new normal for enterprises. 89% of enterprises that have adopted cloud use a multi-cloud approach. Multi-cloud network is key to accelerating enterprise adoption of cloud. However, multi-cloud network still faces challenges in use, experience, and security. To overcome these challenges, IP protocols must evolve to IPv6 enhanced, which offers routing flexibility and application awareness. In addition, enterprises are seeing significant growth in the number of IoT devices, so we predict that IPv6 enhanced penetration will reach 50% by year 2025. When it comes to data center network, the explosive growth of computing demand will increase connected compute nodes from the current 10,000 to 100,000, or even 1 million by 2025. Therefore, data communication networks must continue to improve to better adapt to these changes. For campus network, Wi-Fi 6 will upgrade to Wi-Fi 7. This will improve enterprise office experience and provide full wireless coverage to all workplaces, from offices to production facilities. For WAN, we need to increase network capacity, accelerate end-to-end IPv6 enhanced deployment. For data center network, we will introduce higher speed ports and intelligent lossless Ethernet technologies that can cope with growing computing demand. We will introduce AI to campus network, WAN, and data center network, making them more autonomous and intelligent. More importantly, we must define and shape the development of the net 5.5G industry together. Looking ahead to 2025, we will build 10 gigabit enterprises. To achieve this, campus wireless access must evolve to Wi-Fi 7. We expect Wi-Fi 7 APs to hit the market in 2023 and to see large-scale commercial deployment in year 2025. These APs will support up to 320 MHz channel bandwidth, 12 by 12 MIMO, in 4K QAM, as well as the peak data rates of over 10 gigabits. This will help provide full wireless coverage from offices to production facilities. In addition, the port rate of campus access switches will increase from the current 10 GE to 50 GE, while the port rate of aggregation and the core switches will increase from the current 100 GE to 400 GE. In terms of WAN, the backbone port rate will increase to 800 GE, while network capacity will also increase. In addition, the IPv6 enhanced protocol will continue to evolve. This will enable SRv6 and APN6 to deliver more capabilities like network programmability and application awareness. It will also support multi-factor path computation across hundreds of thousands of network elements and millions of paths. Data center network will also evolve to 800 GE and become lossless network with zero packet loss. Data plane convergence and dynamic congestion control algorithms will continuously reduce end-to-end latency and unleash computing power. First, let's look at the WAN. With the rapid development of WANs, new key requirements on network architecture are emerging, such as how to ensure an optimal service experience across all scenarios and make the most of networks. To meet these requirements, we are introducing AI to WANs and have proposed intelligent WAN. It includes two parts, intelligent routers and iMaster NC IP. Based on this new architecture, we can create digital twin of WAN, leverage layered AI engines to support the AI application scenarios of WAN, and enable intelligent decision-making. AI native WANs will enable zero-error network, zero-weight services, zero-touch O&M, and ultimately achieve the one-domain autonomy. Next, let's have a look at the campus network. As campus network continue to develop rapidly, we will see some new requirements as well that need to be addressed. This will include how to ensure an optimal service experience across all campus scenarios and better connect the scenes on campus. To meet these requirements, we have proposed intelligent campus network. It involves two parts, network elements including campus Wi-Fi, APs, and switches, and the management platform, iMaster NC Campus. Based on this new architecture, we can create digital twin of a campus network and use layered AI engines to support the AI application scenarios of campus network and enable intelligent decision-making. AI native campus network will offer zero waits, zero faults, and zero touches, and ultimately achieve autonomy in the campus network domain. Now let's take a look at the data center network. As data center network continue to evolve rapidly, some key requirements emerge. These include how to ensure lossless connections, meet performance requirements across various scenarios, such as general purpose computing, high performance computing, and AI computing, and build lights out data centers. So we are introducing AI to data center network and have proposed intelligent fabric. It involves two parts, data center switches and iMaster NC fabric. Based on this new architecture, we can create digital twins of data center network, use layered AI engines to support the AI application scenarios of data center network, and enable intelligent decision-making as well. AI native data center network will offer zero errors, zero waits, and zero interruptions, and ultimately achieve the data center network domain autonomy. Based on our thoughts on the evolution of data communication, Huawei has unveiled its vision for Net 5.5G, which covers 6 areas: green ultra broadband, massive heterogeneous IoT, high resilience and low latency networking, IPv6 enhanced, multi-domain network AI, and ubiquitous network security. Green, ultra-broadband networks provide mobile users, homes, and offices campus with 10 gigabit access. IPv6 enhanced multi-domain network AI and ubiquitous network security provide enterprises with elastic, agile, secure, and easy-to-access multi-cloud networking. High resilience and low latency networking enables the interconnections of millions of computing nodes, accelerates centralized industrial control, and makes flexible manufacturing a reality. Massive heterogeneous networking enables ubiquitous IoT connections in industrial facilities and campuses. Together with our industry partners, we hope to set the standards for Net 5.5G, define directions for key products, and create a better future for data communication. Now let's move on to Autonomous Driving Network, or ADN. As we move towards the intelligent world, the ICT industry is facing shared challenges, like complex O&M, diverse services, and the increasing energy consumption of networks. These challenges are all growing exponentially, but the number of O&M engineers is expected to remain basically unchanged. This will lead to a widening gap. To address these challenges, we must systematically introduce AI and enhance network autonomy. Therefore, the architecture transformation is becoming a must. The communication industry has developed standards for different levels of autonomous networks by referring to the standards used for autonomous vehicles. Communication networks are moving from level 2, partially autonomy, and level 3, conditional autonomy, to level 4, which is high autonomy. A higher level of network autonomy can drive network upgrades in many areas. For example, a higher level of autonomy means better user experience. This is because at higher levels of autonomy, the time required for service provisioning and change is not just acceptable, but it can be guaranteed. In addition, more self-services are available, including intelligent service recommendation. A customer experience is not simply guaranteed, but exceeds customer expectations. A higher level of autonomy also means more efficient network O&M. When networks reach level 3, most faults can be self-detected and self-diagnosed, and network performance and quality can be optimized according to specific scenarios. When network evolves to level 4, service can remain uninterrupted during network equipment upgrades. Common faults can be self-rectified, and the coordinated optimization of network performance and quality is possible. In terms of continual learning and evolution, as networks become more autonomous, humans and machines will work more closely to generate and evolve knowledge. In September 2018, Huawei proposed the idea of autonomous driving networks for the first time at the Ultra Broadband Forum in Geneva. 4 years down the road, we have developed a series of intelligent solutions that cover multiple fields like network, computing, and storage. As a part of commitment to intelligence for ICT, we are systematically applying AI to ICT infrastructure. Our goal is to solve key challenges and bring the intelligent world closer than ever. From proposing the architecture to developing a series of solutions, we have passed major milestones on our way to making intelligence for ICT a reality. As these solutions are launched and deployed at scale, we hope to see telecom networks, or even ICT infrastructure as a whole, reach a new level. This graph gives an overview of our ADN solutions. Since intelligent solutions for most domains have just been briefed, here I would like to talk more about Intelligent Service Engine in detail only. The main purpose of Intelligent Service Engine is to help operators implement closed-loop management from service goals to network domain goals. This solution includes key components like a domain knowledge engine, business intelligence engine, hyper-automation engine, domain app development engine, and digital twins. It aims to deliver superior user experience, support efficient O&M, and enable business success. Allow me to explain. With AI and network and environment digital twins, Intelligent Service Engine can intelligently assess real-time experience in terms of different situations, tasks, times, and locations. This can help create a new experience-driven model that enables continuous optimization. This solution can also connect data breakpoints and help create a model that supports real-time, accurate business network linkage and forecasts. These features combined can enable intelligent business operations that can make sense of the present and predict the future. For simple O&M events, the virtual employee supports zero-touch O&M. For complex events, we can implement event analysis and decision-making based on domain knowledge and machine intelligence, and then develop a professional scenario-based O&M system where different roles, size, and tasks can coordinate. Through these functions, Intelligent Service Engine can ensure closed-loop management from operator's service goals to network domain goals, ultimately supporting network-wide autonomy. Based on our past experience, we have summarized 6 design principles for ADN architectures to further advance intelligence for ICT. These include principles for general design, business agility, efficient O&M, system reliability, sustainability, and energy saving, and system learning and evolution. These principles are explained in detail in the ADN white paper. Here, let's look at the general design principle in more detail. First, closed-loop autonomy by layer. For example, a closed loop can be created at the network element layer from an operator's network goals to network element goals. Each domain's control platform can help create a new closed loop from service goals to network goals. With Intelligent Service Engine, another closed loop can be created from customer intent to network goals. This combined can enable a network-wide autonomy. Second, allowing continual learning and evolution. This means the network can undertake associative learning regarding states, actions, and outcomes, and then generate and apply new knowledge. This ensures the network gets smarter the more it is used. Third, using a hybrid architecture driven by both data and models. A conventional architecture only supports analytical methods. However, a hybrid architecture supports both analytical and numerical methods, improving system performance and reliability. Fourth, enabling task coordination between humans and machines. Through this model, humans are out of the loop and command machines. This allows humans to focus more on service innovation, network evolution, and other key challenges. Fifth, allowing distributed intelligent load balancing between machines. This approach can support larger-scale complex networks through collective intelligence. Six, allowing humans to take control of the system under any circumstances. This ensures the network continue providing services in any scenario, such as during machine faults or extreme disasters. This is the bottom line principle. Now let's move on to computing. The digital economy has become a key driver of economic growth worldwide. This has driven an exponential increase in data. We estimate that the amount of new data generated in year 2030 will exceed 1,000 zettabytes. That is 23 times that of 2020. Unstructured data, such as text, image, voice, and video, is expected to account for over 80% of this data in year 2030. The processing of such massive amounts of diverse data requires diversified computing power. We estimate that by year 2030, total general-purpose computing power will see a 10-fold increase, reaching 3.3 zettaflops. We also expect AI computing power to increase by a factor of 500 to 105 zettaflops by 2030. In response, the computing industry must change and pursue architecture innovations to overcome bottlenecks with CPU-centric architectures. This will allow the industry to meet requirements for massive and diverse data processing and adapt to the era of diversified computing. Moving forward, we will need to redefine computing architectures to realize DC as a computer. How? First, we need to evolve from the current CPU-centric heterogeneous architecture to a decentralized peer-to-peer computing architecture that supports diversified computing power. This decentralized approach can break down both I/O and memory walls, greatly improving bandwidth and reducing computing latency. Ultimately, this will greatly boost the system performance. Second, we must upgrade the hardware system from server-based to cluster-based. We will constantly innovate in cluster computing architectures. Now, we will also leverage the technical expertise we have built up in the ICT field to integrate computing, storage, networks, and energy. This will turn a data center cluster into a set of hardware, maximizing computing power density and minimizing power consumption. Third, at the foundational software layer, we will see a shift from a siloed architecture that supports single computing power to a converged architecture that supports diversified computing. This means reshaping foundational software like acceleration libraries and compilers for different processing units. Such measures will improve application development efficiency and performance. Through such architecture innovations, we can realize DC as a computer and increase effective computing power by 10 times. This will allow us to better adapt to the era of diversified computing. Now let's take a look at the data storage. Storage has always been a strong foundation for high-value data. There are 3 clear changes in the storage field. First, unstructured data is starting to see wide adoption in enterprise. 56% of enterprises use AI for at least one business function, with numerous scenarios based on unstructured data. Second, data applications are becoming more diverse. In addition to traditional database applications, new technologies and applications such as virtualization, containers, big data, and AI are constantly emerging. On average, an enterprise has over 100 applications. Third, multi-cloud strategy is a new normal for enterprises. 89% of enterprises that migrate to cloud now use a multi-cloud strategy. As we enter an era of diversified data storage, we must redefine storage architectures and improve storage performance. This will allow us to address the rapidly growing amount of unstructured data and meet enterprises' requirements for diverse applications and multiple clouds. We also need to use AI to enable autonomous and intelligent data storage. Storage architecture innovations mainly focus on reshaping hardware and software architectures through a data-centric approach and using various data applications acceleration engines. This combined can improve storage performance by 10 times. Currently, data flows across two buses, the DDR memory bus and the system PCIe bus. A global data bus with high throughput allows us to integrate these two buses, greatly improving data flow efficiency. In the past, data was indexed and cached at each layer, from application and computing to network and storage. In the future, control and data plane separation will greatly reduce data access latency between applications and the storage pool. For all applications, including service logic and data processing, we can place processing power near the storage system based on application features. This will enable near data processing and thus accelerate applications. As data storage rapidly grows, enterprises want to provide a consistent experience both on and off the cloud, and enable real-time data processing and automatic management. To meet these requirements, we propose the intelligent storage solution, which embeds AI into data storage. This aims to enable autonomous and intelligent data storage. With intelligent storage, we can support autonomous decision-making in scenarios like the layout, scheduling, and reduction of different types of data within storage devices. Intelligently allocate CPU and memory resources to overcome local resource bottlenecks. Enable automatic root cause analysis for unknown faults across all scenarios, and enable data flow and applications deployment in a multi-cloud environment. Finally, let's take a look at Huawei Cloud. Cloud native has become the preferred choice for enterprises to migrate to the cloud. That's because cloud native can bring new value to industries. For example, the data governance pipeline reduces the data development cycle from days to hours. The Pangu large AI models improve scenario coverage by 10 times and comprehensive performance by 10%. Industry-specific APaaS services allow industry know-how to be replicated and support lightweight application development. This can shorten the application development cycle from 3 months to just 10 days. Security capabilities are being deployed more on the cloud. According to McKinsey, in year 2016, 10% of security products were delivered via the cloud, while 90% were delivered on-premise. By 2020, 60% of security products were delivered via the cloud. The new value being created is taking the cloud industry to a new level. By 2025, Gartner estimates that over 95% of new digital projects will run on cloud-native platforms. So it's fair to say that the cloud-native platforms are the way to deepen digitalization. Moving forward, the cloud industry will drive ongoing evolution to cloud-native platforms to create greater value. In terms of data and security, we will harmonize AI development and data governance to unlock more value from data. We will use cloud security brain to enable efficient and secure enterprise operations, as security is the foundation for enterprise to go digital. In 2020, we proposed Cloud Native 2.0 to enable all businesses to become new cloud natives. Our innovations around Cloud Native 2.0 focus on 3 areas. First, infrastructure as a service. We are working to build global infrastructure and networks that deliver a consistent experience and give single-point access to global customers. To achieve this, Huawei Cloud will continue to expand its global data centers and acceleration networks, and create cloud coverage with just 50 millisecond latency. Second, technology as a service. We continue to push the boundaries of foundational technologies and make these leading technologies available to customers and partners through cloud services. This is making innovation easier. We are also upgrading our three major pipelines: the software development pipeline, DevCloud, the AI development pipeline, Model Arts, and the digital content pipeline, Meta Studio. In addition, we launched our data governance pipeline, Data Arts, this year. Third, expertise as a service. We aim to create and share value for greater success. That's why we make both our own and our partners' best practices in digital transformation available on the cloud. We also plan to create industry-specific APaaS services for shared excellence. This year, Huawei has launched a series of APaaS services, including those for industry, government, heating, coal mining, and education. Through these efforts, we hope to drive ongoing cloud-native evolution to create greater value. Let's talk a little more about harmonizing AI development and data governance. 97% of organizations are now investing in big data and AI, and the value of data is becoming more apparent. How can we unlock more value from data? We believe that harmonizing AI development and data governance is the key. There are 3 steps to this. First, we need to unify data storage, reduce redundant storage, and cut invalid data transfers. Second, we must unify metadata. This requires 5 capabilities: unified engine metadata, unified permission controls, unified data indexes, unified data directories, and unified transaction mechanisms. This will make data globally visible and allowing every piece of data to flow freely and be rapidly shared across multiple engines. Third, we need to create a unified development environment where different roles can play to their strengths and obtain what they need. For example, data engineers can use tools they are familiar with to invoke AI capabilities, enabling collaboration between big data development and AI development. Through these innovations, we hope to further improve data development efficiency, cut data storage costs, and unlock more value from data. Now, talk more about cloud security. Cloud native is essential to deepen digitalization, while security is the foundation of cloud. Today, industry-leading enterprises spend over 10% of their IT investment on security. Security covers both system building and operations. That means performing security operations and developing security defense are equally important. Huawei Cloud has used technology to build 7 layers of defense that ensure platform security. Through DevSecOps, we've embedded security into the development and operations of all services. With DevSecOps, we've also developed over 220 secure and trustworthy cloud services. In addition, we provide customers with a wide range of security services, including over 20 in-house security services and more than 400 security ecosystem products. With these services and products, we want to help customers build comprehensive security protection systems. Almost all businesses invest in building security systems. However, these systems can still be compromised during business operations. That's because they lack the right operation capabilities, experts, or configurations, or they fail to effectively monitor, detect, and handle such threats. In response to this, Huawei Cloud has launched the Cloud Security Brain. By leveraging the security capabilities Huawei has built up over 30 years in Huawei Cloud's operation experience, we provide these capabilities and expertise as a service, so customers can build their own operational security systems. These systems include over 300 threat detection models and over 100 security response scripts. that can automatically handle threat alarms. These models and scripts can allow customers to respond to 70% of threats within 2 minutes and 99% of threats within 5 minutes. Generally, fewer than 10 events need to be manually handled each day. Cybersecurity and privacy protection are and will always remain Huawei's top priorities. Security, stability, and high quality are the lifeblood of Huawei Cloud. As a cloud service provider, we are committed to building a secure, reliable, and trustworthy cloud platform so that customers can migrate to the cloud without worry. A journey of 1,000 miles begins with a single step. A bright, intelligent world lies ahead. Let's work together to advance the industry towards the intelligent world. The Striding Towards the Intelligent World white papers will be available shortly. For more details about our findings, please download the white papers. Thank you.